Hello everyone, my name is Timothy Lee Grant and welcome to this video. And today I am going to be starting a new project. And now with any project, we first need to try to figure out okay, we're given a project. What does it need to do? What is it trying to accomplish? Who are the stakeholders? Who's the customer? All of these different questions, right? When you're given a project, it's very ambiguous of what's going on. And so one of the roles that I need to do is take this very ambiguous idea and actually refine it into, okay, well, what is the project actually going to do? So in this video, that's what I'm planning to start off this project series with is, okay, I want to do this project. What what is the goal of it? What should it do? How should it work? What is the architecture like? All of that kind of stuff. First, nail that down and then start moving on to, okay, well, how do we design it? What do we want to do? And actually building it. So that's kind of where this video is going to be. And then in the next video, we'll kick off the building of the actual project. So let's start with our favorite thing, documentation. Okay, so here's what, that's a little bit too small. There we go. That's better. So here is the design document that I created this morning. So first thing is customer requirements. Who is our customer? So what I said is for this project, the customer is the tech companies who are offering back-end software engineering roles. Okay, so normally the customer is going to be whoever, right? You're building a project and you're trying to sell this service or something like that. But that's not actually what I'm trying to do. This project isn't meant to be useful, right? I'm not planning on taking this project and actually distributing it out or building up a huge company from it or anything. No, 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 no. The point of this project is what? Is to demonstrate those skills which are important and valued by the customer. And who in this situation is the customer? Well, it is those tech companies, right? So the next question that I had is, okay, well, that's my customer. What are their requirements? What do they want? And actually, very graciously, they tell me, right? So you can actually see it up here. I went and I looked at some job postings. Okay, and in those job postings, they'll tell me oh, this skill is required for this role. This skill is required for this role. So I looked at a whole bunch of different job descriptions, and from that, I kind of compiled a list right here, right? So kind of compiled a list of a lot of the things that I kept seeing over and over and over. Then what I decided to do is I took that list right there. I said, okay, well, this is the initial requirements. Now, then I took it and asked ChatGPT about, okay, well, here's a list of items, and all of these I want to be able to accomplish, and I explained the context of I am trying to do a project whose purpose is to be able to demonstrate those skills required for back-end software engineering. So I described it to ChatGPT. I said, give me more requirements, organize them, and feel free to add more, right? So this is actually very similar to a real project that I have to do when I'm at my work for embedded systems, right? So when I'm first given a project, my manager will come up to me and he'll be like, okay, Tim, we want a project to be able to go into our new hardware system, okay? Or we want firmware to be able to go into the hardware that we're getting. And so I say, okay, right? It's very vague. just write the firmware. So the question is like, okay, well now I need to go and talk to all of those stakeholders. I need to go to systems and see like, okay, well first I can talk to my manager, be like, okay, well, was there any direction from up above of what this project is hoping to accomplish? And he'll obviously have a lot of information about not how the firmware is going to operate. That's my responsibility to figure out. But he'll have an idea of what overall the entire system wants, or what the entire system is intended to do, to give to the actual customer, right? The end customer, I should say. So I'll listen to him, right? Take that in. Then go talk to the other stakeholders that might be involved. So the systems and networking group, or if there's a hardware engineer who is in charge of developing the hardware for this system, or whoever I think might be a stakeholder in this project, right? And then from that, okay, now it's time to kind of condense what they said and figure out what are my requirements actually going to be and how do I want to design it. So in this situation, I listen to all of the different stakeholders, right? This job posting, that job posting, that job posting, that job posting. And now trying to absorb that information and actually coagulate it into something which is a more fleshed out, defined project. Okay, so this is what it's saying. We don't need to follow everything, right? Like, and this is for a normal project as well. There's going to be conflicting desires between all of these different stakeholders, and it's kind of our responsibility also to balance that out. Now, normally, in a normal situation, is if there's conflicting things, you would need to go and actually have a negotiation between the two parties who are disagreeing in scope or requirement. But in this case, because it's only me doing it, there's no really negotiation. But so these are not set in stone that have to be there, but these are the things that, okay, this project, it needs to demonstrate a lot of these points. That is the purpose of this project. That is the end goal of this project. Now we're going to be reverse engineering. Okay, well, let's figure out something that fits this, right? So it's actually a little bit flipped than how a normal project would normally operate, which is, well, they give you the goal of what it should do, and then you figure out like, okay, well, I'm going to be using this and that technology. But it's kind of the nature of how things are for this specific thing, because it's kind of a strange context, or end goal, I should say, where we're not focused on like usability of the project and making it useful, but rather it's flipped. Now it's a demonstration of skill or of competency with certain concepts. So let's just go through some of these, and I will talk about the ones that I think are most important and that I definitely know should or need to be in this project. So microservice architecture, that's a need. I saw that all over the place, and I know that that is extremely useful, extremely important for software engineering, back-end software engineering. That's going to be in there. Okay, RESTful APIs, again, that's kind of a given. Okay, cool. GraphQL, and I just put it like no. So I'm going to be using either SQL or NoSQL. So we're not going to be doing graphs. There. Authentication. Yeah, okay. API versioning, rate limiting, okay. Error handling, caching, Maybe. I don't know about those. So now languages and frameworks. Okay, well, Node.js and Spring Boot. That's the two, and there was actually a lot more that it gave me. I narrowed that down. I said, no, I'm only going to be dealing with Node.js and Spring Boot. Though I saw that all over the place, I know that those are extremely important, so we're going to be limiting our scope to those. Databases, so as I said up here, relational database, either Postgres or SQL. And then for the NoSQL, I just said we're going to be doing MongoDB. All right. So now unit testing. This one I know is also important, these two, Mockito and JUnit. So we're going to be adding those. Integration testing, yep, end-to-end testing is important. Now, these three, I know Postman, but I only know it as like a tool that you can send REST requests to. So I don't know how it really integrates into end-to-end testing, but we'll have to figure that out when we're actually doing the project. Contract testing, I don't even know what this is. So I was debating on if I just delete it, but then I'm gonna look into it a little bit more. CI/CD, yes, this one. I heard a lot about CI/CD and how that's important. Containerization, so these I feel like are something which are more at the end stages of this project. So once the project is actually operational, okay, well then we can figure out how do you containerize it with Docker, how do you actually do the pipelines, all of that stuff. So that's more later. Okay, so this one, metrics collection. Now, this is one that I did not see in a lot of the job postings. But I know when I talk to my friends who are in those companies, they tell me that this is extremely important. So I'm debating on, do I want to add metrics collections to this project, or do I want to not? And the argument against it would be, well, I don't want to be making this a Frankenstein project where it's just in 10,000 different directions. But I do want to do metrics collections, and it might be something very similar to up here where it kind of comes later. So we might do that a little bit later, like logging, tracing, all of this stuff, monitoring and alerts. I think this is more of a after the project is a little bit more functioning, then we can start adding those in, and I don't think it's going to hurt or degrade the project by having that later or doing it last. I think it's fine. So documentation. So this one is, I'll be using Swagger. I'm going to get rid of this. I don't care about OpenAPI, Swagger. Okay, so now internal documentation. So this is more of kind of what I'm doing right here, where I'm actually documenting how I am doing the project. So like this entire documentation, right? Like not just jumping into it. Input validation, sanitization, rate limiting, all of this stuff for security. Maybe, probably not. Because I didn't see a lot of this. It's important insofar as like if I was going to be building something that was to be used, obviously this would be extremely important. But what is the customer? Who and what do they want, right? And so I think maybe we just don't do this one. External integration, again, I saw some about Kafka, but the other ones, like third-party API integration, I mean, this one would be really nice, but it kind of feels like a Frankenstein, maybe. So maybe, but I don't know about that one. All right, so design patterns. I know that this was on a lot of the postings, and they were saying like whatever 3+ years of design patterns or some, I forget the exact verbiage that they were using, but I know that this one is definitely important. So I need to on my own time also just like go through each of these and try to understand that more. All right. So this is kind of like the initial talking to the customers, talking to the different stakeholders, trying to figure out like what are they wanting? What is this project even going to do? And then I thought about it, right? I went online, I talked to my customers, talked to my stakeholders, and then I thought about it. I was like, okay, well, what kind of project can I do that meets the most of these requirements and also kind of makes a little bit of sense, right? And so this is kind of what I'm thinking. So I created this thing of architecture. So I'm gonna have we have the client side right here, and we have the server side right here. So what I'm thinking is we're going to have a application where a user is able, we have two groups of users, like producers and consumers, and I call them also like suppliers and demanders, right? And they're able to go in, and a producer is able to add inventory, okay? And a consumer is able to consume inventory. All right, so that is what this project is going to be doing. That's like the very high level of how this project is going to be, what this project is, the way that I can say it. Now, all right, what architecture are we trying to do? So we have these different roles that can be played. We also need a login page and a create account. So this kind of goes into the persistence that we've been that I was investigating a couple videos, or I forget when. I think it was like a week ago, 2 weeks ago. I've kind of lost track of time. I've been going full force on a lot of stuff recently, but in a video that I made a while ago, I was very curious about, okay, well, how does the server keep information and context to service client requests? And we got into the web tokens and all of that kind of stuff. So we need to have that persistency. So they're going to log in with an account, with their account. And with that, they can go to the different web pages, and they're going to be able to continue using that, or not need to re-log in every single time, right? So now, here are our two microservices, consume resource and supply resource, okay? Now, this microservice is going to handle all of the logic that will be required when you're trying to add an item to inventory, okay? And likewise, this one is, the consume is take away. Supply is when you're adding an item to inventory. So, okay, they're going to come in. The producers are not going to go and directly send a request all the way to a supply resource. It's going to go through this API gateway. So this gateway is going to be the one who's kind of in charge of routing, okay, well, I got a request from a producer, I need to send it to the supply resource. Okay, I got a login request, I need to verify their identity. Okay, I got a request from a consumer, I need to route it to the consumer resource. And now, what will this API gateway need? Well, it needs the database for login information. So it needs to know who the people are, what's their username and what's their password. And then it can also, we have a create account so that the API gateway can add more people to it. Now, we have this items database that consume resource and supply resource are able to either add data to or take data away based off of who's doing what. So this is the overarching architecture of how I want to set up this project. All right, so, and then I describe it down here. So main page will be a login page where the user can enter their login credentials to gain access into the site. After login, the user will be able to add supplies or take supplies. A consumer will only be able to take supplies that are currently available, but a producer will be able to supply any item. If a consumer attempts to consume an item that does not have inventory, hold on. If a consumer attempts to consume an item that is not in inventory, this will result in the consumer getting a message informing them that the item no longer exists. Okay, so high-level design, API gateway. So we wanted Node.js. So this covers Node.js, it covers JavaScript, it covers Express, it covers EJS because we're going to be rendering these with EJS. And so we hit 4 bullet points with just this one design choice. Login information. So I need to figure out, should I be using SQL or no SQL right here? I don't quite know yet. And notice in items, it needs to be the opposite because we need both SQL and no SQL. So whatever choice I make, I need to invert it for the other one. And just thinking about it, like actually if we have more items than people, it might make sense to have this one optimized for lookup, and that kind of forces my hand to be the opposite for that one. Anyways, so we'll have to think about that a little bit more. So consume resource microservice. All right, so these 2 microservices here, they're going to be Java with Spring Boot. Okay, so we were able to hit a lot of those points that were the main objective of this project. So client-side web pages here. Web pages rendered through Express EJS must allow users to go back and log out from their web pages. So now API gateways, persistent user identification. That's what I was mentioning about user will not need to keep logging in. Okay. And registry service. This has to do with the fact that, like, I need some way to keep track of how am I sending and where is what IP and port number is this consume resource. I have no idea, right? It needs to register itself. So I need some kind of registry that the API gateway is going to be able to use. Let's see, rate limiting. So that was another one that was mentioned a couple times up there, which was rate limiting. The API gateway can do that. So that hits another one of those things. So I think what I'm going to do is use the token bucket methodology to limit each user 50 requests per minute. I can't imagine during operation we're going to be going over 50 requests per minute, and so that just gives us a way to make sure that a user isn't entering 1 million requests and crashing the server. So that also shows the consideration of security and robustness. Okay, so the other thing that I said is load balancing is not required because we're only having one microservice for each main component. What I mean by that is like consume resource, we only have one microservice for consume resource. In theory, what we would be doing is and this is why microservices are so good, is because if we think that we're going to have a lot of consumers but not very many producers, we might be able to do 2 microservices running together. Both of them are just consume resource microservices. So we can have 2 or 3 or 10 of these and only one supply resource microservice. And then what we'd need to do is, because we have multiple here, if this API gateway gets a request and it is for consume, it needs a load balancer to be able to go in and route. Well, I'm going to talk to this consume resource number 3 instead of number 6. But we only have one here and one there. Looking long term into the project, I mean, that's something that I can add in the future. There's nothing that stops me, right? So I'm not blocking myself in, but it's also currently not part of the scope of this project. Okay, let me get some water though. All right, that feels better. I was talking for too long. All right, so consume resource. So these things, the consume resource and produce resource, they are 2 separate microservices that will handle logic of adding resources to the database or taking resources away. All right, item database, Postgres, SQL. This one, I just said it. I don't know, that we might change these, right? And these need to be inverse of each other. So this one is relational, and this one is no SQL. So yeah, that is the design document and kind of how I was started this project, how I started conceptualizing it, how I went from, okay, well, what is the point of this project? What is it supposed to do? Coagulate or grouping, that's a nicer word. I don't like taking in all of that information, trying to create a cohesive working concept. More well-defined, not just something ambiguous, and then bringing it into like, okay, here's what we're gonna do. Hold on. Here's what we're gonna do. Here it is, right there. Now we have something that we can actually move forward with. So in the next video, that's where I'm gonna actually move forward with it. So look at this, try to figure out how does it work? Like, okay, we have this diagram that I made. It's a how do we actually go about designing this and creating it? So a lot of the stuff I have no idea. I don't know how I'm gonna do it, right? I have no idea. But I mean that's the way it is all the time. I feel with engineering is whenever my manager gives me a task, I'm like, or a project, I'm like, I have no idea how I'm gonna do it, but I'll figure it out, right? Oh, we need you to do XYZ. Obviously, I can't discuss too much what I'm doing at work, but give me a high level request for do this project, and then I said, okay, well let's try to. I have no idea how I'm gonna do it. Once I define my project, most of the components I have no idea how I'm gonna do it, but just work on each one, try to get things working, and yeah, so that's gonna be in the future videos is trying to actually build this out. So if that is interesting to you, subscribe to this channel. I would love to have you here and join me along in this journey. I hope everyone has a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you in the next video.